That's weird. I wonder why this isn't working. Hmm. 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 Hello? I'm wondering if you guys can hear this. I don't think so. I think this should work. 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 That's gonna go on forever, isn't it? I think this should work. That's gonna go on forever, isn't it? I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever, isn't it? That's not. I think this should work. That's gonna go on forever.
That's funny, dude.
So we don't want audio output capture. What do we want? Well, I'm just gonna put the browser on here. Let's see. That's not the right one. We're gonna do this one for now. We're gonna do this one.
So we have understood recursion.
We're gonna do this one.
So we have understood recursion.
We're gonna do this one.
So we have understood recursion. So we have understood recursion. So we have understood recursion.
Why does it do that?
We have understood recursion.
That is so strange. That is so
So
strange.
we have understood recursion.
So understood recursion.
We have understood recursion.
Oh my god.
We have understood recursion.
Oh my god.
We have understood recursion.
Let's try that again. I think the problem is. No, that's not the problem. Oh yeah, this is the problem right here. There we go. I think that's better, yeah. I'm gonna
but we don't know what exactly a factorial of a number is. So let's understand factorial and move on to recursion to calculate the factorial. A factorial of any number is denoted by this. So for example, if I want to calculate factorial of 5, it is denoted by 5 and then an exclamation mark. So this is called as a 5 factorial. And mathematically what this essentially means is that 5 factorial means you take 5, multiply it with a number less than this, so 5 into 4, and then you keep on reducing this number unless and until this number is reduced to 1. So you say 5 into 4 into 3 into 2 into 1. So this is what 5 factorial looks like. And remember that we stop at 1, we don't go ahead and we don't multiply this thing with 0, because in that particular case the final factorial result would finally become 0. So the factorial of 5 is 5 multiplied by 4, which is 20, multiplied by 3 is 60, multiplied by 2 is 120. So the factorial of 5 is said to be 120. So this is how you could go ahead and calculate factorial of a number. Similarly, a factorial of a number 3 would be something like 3 into 2 into 1, and we stop there. So the factorial of 3 is said to be 6. So now what we want to do is that we want to go ahead and calculate these factorial values of any given number using Python. So how exactly this could be done? So this could be done by just creating a regular Python function, but this could also be done by making use of the concept of recursion. So in the concept of recursion, what we do is we call a given function within the function body or the function definition itself. So let's go ahead and let's try implementing this factorial by creating a Python function. So I'll create a function called as factorial, and over here this function is going to accept a number. So for example, if I want to calculate 5 factorial, I could pass in the number 5 here. So once we have this number, what we do is, if that particular number is 1, so for example, what happens if we want to calculate 1 factorial? So 1 factorial is always going to be equal to 1, because it's essentially 1 multiplied by nothing. So therefore here we say that okay, this function should return a value 1 if the number is 1. So I could say if the number is equal to 1, in that case simply return 1 as the result, which is actually true because factorial of 1 is always 1. But what happens to other numbers, such as what if the number is actually 2, 3, 4 or 5? In that particular case I would have that code in the else block. So here what I would do is, whenever you have to calculate the factorial of a number, so for example if you have to calculate the factorial of a number 3, what you would do is you would say take the number 3. So here in a similar fashion we return 3, and we don't just return 3, but instead we want to then multiply this particular number with a number which is 1 less than this. So here I essentially want to say 3 minus 1. So instead of 3 minus 1, I could also go ahead and say I want the number minus 1. And then what we do is we again take the number, so we say multiplied by, take the currently modified number, which is again the number here, and then keep on subtracting 1 from it. So that means now the value of this becomes 2, then we take 2 and again subtract 1 from it unless and until the number reaches 1. So here I would say instead of 3, I would say take the number and multiply it with the number minus 1, and we want to keep on doing this till the point the number reaches 1. So here instead of saying into number minus 1, what I would do is I would instead multiply this and call the factorial over here itself, which is nothing but the same function here. But this time instead of passing a number here, what I would do is I would say number minus 1. Now let's take an example to understand how this works.
Correct. So if the number equals 1, then return 1. Else return number times number minus 1. Oh, that's why. Because we didn't call the recursion. That's the recursion. So we're making it cycle through until it goes down to 1. Because we're subtracting 1 from the number, which is this is the number. So if the number is equal to 1, return 1. else return number times the factorial, which is 5 times the 5 technically, and then we subtract 1, so it's actually 5 times 4. And then it goes back again because you're calling it again. Now it's 4. It's not 1, so it's going to go here, then do 3. It's going to subtract 1, go back again. It's not 1. It's going to do 2, go back again, and now it's 1. Okay, let's try it. 120. Let's do some retarded number.
So
Okay.
let's take a simple example of calculating a 3 factorial. So I'll go down here. So let's say I want to calculate 4 factorial. So let's first execute this function and see if that works, and then let's try to understand how this works. So I would say print, call the factorial function, pass in 4 here. So the 4 factorial is 4 multiplied by 3, which is 12, multiplied by 2 is 24. So if you run this, as you can see, you get the
You know
result as
something interesting? I think I tried this earlier. Let me try to print factorial 5. Oh, it did work. Last time I tried this, it didn't work. But I prefer to do it this way anyway.
24. Now the way in which this works is that when you actually call this function for the very first time, so if you say factorial of 4, technically what's happening is this thing is going to return. So let's say this thing returns, so it will take the number 4 here. It's going to find out that number is not equal to 1, therefore it's going to execute this code right here. So when we say factorial of 4, it would simply say return the number, which is 4. So it would say 4 multiplied by factorial of, that is going to be 4 minus 1. Now what happens is the factorial of 4 minus 1 is 3. So it would say return 4 multiplied by factorial of 3. Then it will go ahead and try to calculate factorial of 3. So here in the next iteration it will calculate the factorial of 3. So factorial of 3 is going to say return, this time the value of this number is 3, therefore it will return 3 multiplied by the factorial of, that is going to be 3 minus 1. So that is 3 minus 1 is 2, so it will return a factorial of 2. Now it will go ahead and calculate the factorial of 2. So the factorial of 2 is going to return this number of 2 is going to return, the number here is 2 in this case, so it will say 2 multiplied by factorial of 2 minus 1, which is 1. And then finally it will calculate the factorial of 1. So it will say factorial of 1, and that's going to be equal to return 1, and whenever it returns 1, it will pass in 1 over here, and then what happens is if the number is 1, it will simply return 1 here. So finally we are left with 1. So what happens is it will keep on calculating the number, or it will keep on trimming down the number by 1 every time this particular recursion happens. So ultimately what happens is it will simply go ahead and multiply 4 into 3 into 2 into 1, and therefore we get the result as 24. So this is how recursion works in Python. And using recursion, this is how we could calculate the factorial of a number. So essentially what we have done here is that we have called this function once with the initial value. Then it's going to take that initial value, return that value multiplied by whatever factorial of this thing is, and the factorial function is going to further trim this number down by 1 every time this loop executes. So this is how recursion works in Python, and this is how you could use recursion to calculate factorial of a number.
The only thing that I'm kind of curious about is, so we have this returning the number times the factorial number minus 1. So you're running this whole program again. Why then at the very end, when this number becomes 1, isn't it just return 1? I find that a little interesting, but I think we will find that answer out in the future some
So
point.
that's it for this lecture. and I'll see you guys in the next one. Thank you. In this particular lecture, let's learn about variable length arguments in Python. So whenever you create a function in Python, that function accepts a certain number of arguments, and then while calling that function, we pass in certain kind of data to those arguments. So for example, we have created a function which is add, and this add function was able to add two numbers a and b, so we simply say return a plus b. Now this is all fine and good, but there's one problem with this particular function, and that problem is I could only add two numbers here. So I could say add 2 and 3, and I could print up this result over here, and it's actually going to go ahead and add these numbers for us. But what if I actually pass in one more number like 5 over here? In this particular case, if I try to run this, as you can see now, it will give us an error and it will say that this add function only takes two positional arguments, but instead we have given 3 arguments here. And this is actually correct, because if you take a look at this, this only accepts 2 arguments. But what if you actually want to create a function wherein you could pass in as many number of arguments as you want? That is, you should not be limited to only 1 or 2 arguments, but you should be able to enter 3, 4, 5 or any number of arguments as you want. So this is where exactly variable length positional arguments come into picture. So whenever you don't want to restrict a function to only accept a certain number of arguments, what we do is, instead of passing arguments like that, we pass in a variable length arguments or variable length positional arguments. So let's modify this function such that we could pass in any number of arguments here. So instead of a and b, in order to use variable length positional arguments, you have to make use of a star here and then type in args. So when you go ahead and do something like this, now you're able to accept any number of arguments to this particular function. But now the question is, how exactly are you going to be able to go ahead and access these arguments here, because this a and b is no longer going to work in this function. So whenever you pass in variable number of arguments or variable length positional arguments to any function, Python actually stores those arguments as a tuple. So if you have to get access to the arguments here, you have to make use of a for loop here. So you could say for every single number in the arguments, or you could also say for every single argument in the arguments. So it's actually better if I name it n, because the args and arg is going to sound confusing. So this is going to go ahead and give us access to every single argument which we have. So for now, let's simply print up each and every number which we have, which is being passed to the arguments. So if you print this, as you can see, we get 2, 3 and 5 over here. If I pass in any additional number like 10, all of these numbers are going to be passed as arguments to this function, and as this signifies that this function accepts a variable number of arguments, it's okay to call this function this way and pass in as many number of arguments as we want. And in order to use those arguments inside those functions, we simply have to loop through those arguments, and we are able to access each and every number inside that particular argument list. This signifies that this function numbers are going to be passed as arguments to this function, and as this signifies that this function accepts a variable number of arguments, it's okay to call this function this way and pass in as many number of arguments as we want. And in order to use those arguments inside those functions, we simply have to loop through those arguments, and we are able to access each and every number inside that particular argument list. So as you can see, now we are able to access every single number like 2, 3, 5 and 10. So now we have to modify this add function in such a way that it calculates the sum of all the numbers which we pass to it. So once we have access to every single number, I'll create a variable called as sum, and I will initialize it to 0. And over here, I would say sum equals sum plus n, which is every single number which we loop. And then finally, let's print up the value of sum, or return the value of sum. So I could say return sum. Or if you want, you could also make this add function print sum over here as well. So now if you run this, as you can see, we got the sum as 20, which is actually correct, because 2 plus 3 is 5, 5 plus 5 is 10, and 10 plus 10 is 20. So now as you can see, our function now could accept any number of arguments if we pass it. So for example, you could also pass in many other numbers, and this is still going to work fine. So as you can see, we still get the result from this function.
I like doing plus equals instead of sum equals sum plus n. This is pretty much the same thing. I mean, it is the same thing, because we have 19, and then if we took sum equals sum plus 10, still 19. This is just takes, they just put this in so that it's less code, I guess, from my understanding. I like it better, it looks neater.
So by making use of the variable length positional arguments, we are actually able to pass in any number of parameters or any number of arguments to a given function whenever we call that particular function. Now this particular kind of arguments are called as variable length positional arguments, but what if you want to be able to pass in a variable length keyword arguments? So we all know that keyword arguments are something wherein you are able to actually go ahead and pass in the arguments as a key and value pair. So in the next lecture, let's go ahead and let's learn how we could pass in variable length arguments but in a keyword fashion in a
See if
particular
this
function.
works.
So let's learn about that in the next one.
Oh, that does work. Nice.
So in this particular lecture, let's learn about variable length keyword arguments. So these arguments which we have passed here are variable length positional arguments because the position of these numbers matter, because the positions in which we have passed these numbers is the exact same position which we get over here as well. But what if you don't want to be bothered with the positions and instead you want to access those arguments depending upon the keyword values which you pass in? So let's take an example to understand this. So let's say if you actually want to create a function which kind of displays the name and the details of a given product. So for that, what you could do is you could create a function, and let's say we name this function as product, and this time we want to make this function accept different kinds of arguments like the name of the product, the price of the product, and description. So if this was a normal function, you would have passed in some arguments like name, then price, then description, and this would have worked absolutely fine. But this time we want to keep this product function flexible so as to accept any number of arguments which we want. However, we do not want to use positional arguments here. Instead, we want to use keyword arguments. So in case of variable length positional arguments, you would use star args, which is arguments. But in case of variable length keyword arguments, instead of using a single star, we use 2 stars here. And then instead of args, we say kw args, which stands for keyword arguments. And that's it. So now what we could do is we could make this function return anything, and we could also access the different keyword arguments here. So instead of actually writing some code in this function, let me call this function first and let's see how we are going to access those values. So for example, if I call this function here like product, and let's say I want to pass in arguments like the name, price, and the description. So for the first product, let's say I want to say that the name is going to be iPhone, and as this is a variable length keyword arguments function, I could now go ahead and pass in any number of keyword arguments here. So let's say for the first product I want to create, I want to set the name equals, let's say iPhone, and let's say I want to set the next arguments to be price. So I could say price equals, let's say 700, and let's say I don't want to add a description here. However, let's say for the second product which I add here, I want to set the name. I could set the name to iPad. I could set the price to, let's say 400, and I could set the description as well. So let's call this thing as description, and I could say something like this is an iPad. Okay, so as you can see, to this particular function call we have passed in different arguments, and to this one we have passed in different arguments here. So this product only has name and price, however this product has name, price, as well as description. Now once we have these values passed, the question is how exactly are you going to access those values here? So what you could do is you could create a for loop, and what you could do is you could actually get these particular values in a key value pair. So whenever you pass in variable length keyword arguments, you pass them in a key value pair. So in this case, the key is name, the value is iPad, the key is price, value is 400, the key is description, and the value is this is an iPad.
It's almost
So
like
here
a dictionary.
we say for key comma value in, and then I would say keyword arguments dot items. So whenever you have to access the keyword arguments in a key value pair, you have to say keyword arguments dot items. So this is going to give you access to each and every key value pair that exists in that particular product. So here I could simply go ahead and print the values of key and value. So I could say print key, and then to keep things simple, I'm simply going to use a concatenation sign and then use a value here and have some sort of a string in between them, let's say a colon. So now what happens is we are able to get the values in a key value pair. So if you run this, as you can see, now we are actually able to access the name and the price for the first product, which is iPhone and 700, and the next function call which we have here gives us access to the name, price, and description. Now this is just a simple example, but in a complex example what you could do is you could actually pass in some kind of data or some kind of parameters or arguments to a function. Then you could access those particular parameters depending upon the key value pair which we have up over there. So we get the key as well as we get the value which is assigned to that key as well. So this is how you could make a function accept variable length arguments but in a keyword format. That is, you could make a function accept variable length keyword arguments. So in the previous lecture we have learned about variable length positional arguments. So whenever you have to use variable length positional arguments, those arguments are defined by a star and then args, which is arguments. However, kw over here stands for keyword, and as this is not a positional but a keyword argument, you add one more star over here. So that's it for this lecture, and I'll see you guys in the next one. Thank you. In this lecture, let's learn what exactly are decorators in Python and why exactly they are used.
I'm going to be right back. I don't know exactly how to pause the stream, so I'm just going to let it go for now.
So as the name signifies, the word decorator in Python means nothing but something which is used to decorate a function. So typically decorators actually modify the behavior of the existing function which you have. So you could say that whenever you have a function, you have some code inside that function, and let's say if you want to extend the behavior of that particular function by adding some code. Now one way to do this is that you could directly add some code to that particular function, but that's going to change the behavior of that function itself. So decorators allow you to go ahead and modify the behavior of a function without having to write some code in it. So in order to understand the concept of decorators in a much more better way, let's take an example. So here I'll create a simple function called as chocolate, and let's say this function is going to simply print up the word chocolate. So here I could say print, and let's say this thing says chocolate. Okay, so now let's say I want to modify the behavior of this function, and let's say I want to add a wrapper before and after chocolate. So in order to modify the behavior of this function, one thing which I could do is I could simply go ahead and add print, and I could say print wrapper over here, and I could also add a wrapper over here as well, and that's going to add a wrapper to the chocolate. However, let's say if we do not want to modify the behavior of the function, and instead kind of extend the behavior of this function so that whenever we call this function, it should be wrapped up in a wrapper. So in order to do this, we make use of something which is called as a decorator. So once we have this particular function, what we do is we define a decorator. So the way in which the decorator works is that we create a decorator with a name. So we create just as any other function. So we say def decorator, and every decorator function actually accepts a specific function. So in this case, we actually want to take this particular chocolate function and we want to pass it to the decorator function. So over here, I would actually say that, okay, this function is going to accept another function, which is func. So we have simply named the parameter name as func, but we are actually going to be passing this chocolate function to that particular decorator. Now what this decorator is going to do is that the decorator is going to have its very own code as well. So here, I'll create a function inside the decorator called as wrapper. So I would say def wrapper. So this is going to be a function within another function. So what we have done here is that we have nested one function inside the other function. So this is a decorator, and inside the decorator function, you actually need to have a wrapper. And within this wrapper is where you're going to modify the behavior of this function. So let's say I want to print wrapper and wrapper before and after this chocolate. So what I could do is I could say print, and I could say, let's say wrapper upside, and over here I would say print wrapper downside. And what we want to do is we basically want to, let's say, wrap this chocolate hypothetically in between these two print statements. So therefore I'll actually call this function here. So we know that we are going to pass this function over here as a parameter. So I could call this function by simply saying func and simply have a function call in here. So now once we have defined this particular inner function, we are not going to call this function. However, we have to make this function, or the outermost function or the outermost decorator, return this wrapper. So here I would say return wrapper. And you don't have to call this, but instead you actually have to return this wrapper over here. So let's try to go ahead and understand what exactly is happening here. So this decorator function, it accepts a particular function. To modify the behavior of the function, we have another function called as wrapper function defined inside this decorator. And within that wrapper, we actually call that particular main function which we pass in here. And this function which we are going to pass in here is going to be this chocolate function. And finally, what we do is we make this particular decorator return a wrapper. So now let's try to understand how exactly we could actually use decorator with this function. So we essentially want to decorate this function using this decorator. So what we do is, it's obvious that as we have to pass in this function here, that means we need to call this function first. So here I would say decorator and simply pass in the function which is chocolate here. And you don't have to call this function, you simply have to pass in the function name here. And as we all know that this function ultimately returns a wrapper here. So here we are essentially wrapping the chocolate using the decorator function, and this decorator returns the wrapper, which means that it returns the modified function. So let's save it back into the original function, which is chocolate. So I would say chocolate equals the decorator. And then finally, once this function is decorated, that is once this chocolate function is decorated, finally, I could go ahead and call this function. So I could say chocolate here. So now what happens is, if you run this, as you can see, the chocolate is actually wrapped inside the wrapper. So we have wrapper upside, we have wrapper downside, and in between we have a chocolate. So here, making use of a decorator, we have actually modified the behavior of the chocolate function.
Why are your hands greasy? Okay, greaseball. Mmm. Because I'm still in here. Good night, babe.
function, and you will clearly be able to see that we have not modified any kind of code inside this function, and instead we have actually made use of this decorator to add a wrapper to modify the behavior of that function by simply calling that function up over here. So I hope this kind of gives you an idea about what exactly are decorators and how they could be used to modify behavior of a certain function. So in the next lecture, we will learn another way of using decorators in a much more better way. So thank you very much for watching.
So I
and I'll see
understand
you guys
what
in the
we're
next
doing,
one.
I just don't
Thank
know
you.
why we would want to do this. I
In
can't
this
think of a
lecture,
scenario in which this would be a beneficial thing, like in a video game or something. I guess like changing the stats of an item or something. And you run it through a function, kind of like maybe, I don't know, when you're playing Skyrim or something and you're making an item, every time you enchant it or something, it runs it through a function similar to this. I don't know.
well, let's learn another way of using a Python decorator. So in the previous lecture, we had created this particular decorator right here, and we had decorated this particular function using the decorator which we have created. And the way in which we have used that decorator is that you simply go ahead, make use of the decorator function, which is this function right here, and then simply pass
Ain't
in the
nobody
function which you
watching
want to
anyway.
decorate, and then kind of see.
Yeah, I'm streaming, learning how to program. I think it's cool. Judgy eyes from
Save
my
that particular
wife.
function back into that decorator. However, instead of
What's that? That's annoying. I got some up here, I'll squirt it.
writing the code in this way, what we could do is that we could use a better way of decorating a particular Python function. So let's learn about that way of decorating a function in this lecture. So let's get rid of this code from here. And right now we have two functions. The first function is this one, and the next is the decorator. So what you could do is that whenever you have to decorate a certain function, you first have to go ahead and declare the decorator right before this function. And I'll tell you in a minute why. So let's take this particular decorator function, cut this, and put it over here at the top. And now, instead of having to go ahead and call the decorator function and then pass that particular chocolate function into the decorator and then get that function back and save into the chocolate function, what you could do instead is that you could simply go ahead and at the top of this particular function, you could actually make use of the @ sign. And after the @ sign, you could simply mention the name of the decorator with which you want to decorate the chocolate function. So in this case, I want to decorate the chocolate function using the decorator, which is decorator. So here I could say @decorator. And once I do this, what happens is now this function is going to be decorated with this decorator. So if you want to check if that's really true, what you could do is, first of all, you could go ahead and get rid of this decorator from here. And if you run this, the chocolate function will be executed without the decorator, and here we only get chocolate. However, as soon as I go ahead and as soon as I actually paste this @decorator on top of the function up over here, Python understands that this particular function needs to be decorated with this decorator. Henceforth, it will take this particular function and it will kind of decorate this function, or we could say extend the functionality of this particular function making use of the decorator. So let's run this code and let's see what do we get. So here, as you can see, as we have used a decorator, now the chocolate function is decorated using that decorator. So this is how you could go ahead and make use of a decorator in Python. Now, one more thing about a decorator is that once you have created a decorator, the same decorator could be used multiple times as well. That means a decorator once created could be reused. So let's say, for example, if you have a different function here, let's say that function is something like a cake. So let's create a function def cake, and let's say the job of this function is to simply print cake. So I could say cake here. And now if I want to decorate this function using the same decorator which I have used for chocolate, I could do that over here as well. So here I could say @decorator. So now let's also call the cake function as well. And let's see if that cake is decorated as well. So if you run this, as you can see, the cake is also wrapped inside the wrapper, making use of the decorator, and the chocolate is wrapped as well. And that means once you create a specific decorator, you could go ahead and make use of that decorator as many number of times as you want anywhere inside your code. So that's it for this lecture, and I'll see you guys in the next one. Thank you.
Now that I think about it, I feel like enchanting is kind of like a taking an item and running it through this kind of a thing where you, yeah,
However, what if you actually want to pass in some
makes
argument to these
sense
functions?
to
So for
me.
example, Over here for this particular cake, let's say I also want to pass in an argument like name, so that whenever I call this particular function, I should be able to pass an argument. So let's say, for example, after the cake, I also want to display the name of the cake, like let's say apple cake, pineapple cake, so on and so forth. So here, let's say I accept the name here and then simply print up the name after cake. That's the kind of function I want to design. Now let's go ahead and let's pass in an actual argument here when we call this function. So let's say I want to pass in apple here. So if I pass in apple here and if I run this, as you can see, I get an error over here, and that's because we have passed in an extra parameter here or extra argument here. However, right inside the decorator does not accept any kind of argument here. So that means now what we need to do is we need to take this particular function, and whenever we are referring to that particular function here, we also need to be able to pass in that argument here. So what I could do is I could say, okay, as I'm passing the argument to the actual function, I need to pass it over here as well. So I could pass that argument here, but now I'm actually getting an error, and that's because we actually have to pass in the name inside the wrapper, and then from the wrapper it could be passed inside to this function. So let's also pass the name over here as well, and as soon as I do that, the error disappears. Now if I go ahead and if I try to run this time, what happens is I get a new error, but this time I get the error inside chocolate. So if I kind of go ahead and comment the function called to chocolate, this code would work. So if I run this, now as you can see, it says cake apple, and the cake function works because we have passed in a single argument, and we have also passed that argument over here to the wrapper function as well. However, this decorator is now not working with chocolate because chocolate does not accept any kind of argument. And if you try to kind of go ahead and call the function chocolate, it's going to throw an error. So that's the problem. So the problem here is that one of the function actually needs an argument and other function does not need an argument. And the function which does not need an argument, it's not working well with this decorator because now this decorator actually accepts an argument. So one way to solve this is by making use of a variable length arguments inside this particular decorator which we have. So what we could do is that we
it works.
could tell this wrapper that okay, you can or cannot accept arguments as per your own choice as and when required. So we kind of make this particular wrapper a little bit flexible. So what we do is we make this wrapper accept variable length positional arguments as well as variable length keyword arguments. Therefore over here I'll say star args, so this is variable length positional arguments, and then double star kwargs, which is the variable length keyword arguments. Now I have to pass in the same arguments to the function call over here as well. So now what happens is, now we are not going to get an error with chocolate because now these arguments are optional because we have specified that this wrapper could accept any number of arguments. Therefore it is going to work absolutely fine. And even this cake is going to work absolutely fine with this decorator as it could accept any number of random arguments, and we have passed in one argument here. So now if I run this, as you can see, we get the chocolate here with no arguments passed to it, and we also get cake apple here as well, even though we have passed in one argument over here. So making use of args and keyword arguments over here inside the wrapper kind of makes our decorator a little bit more flexible, so that we could also make use of these decorators with functions which actually accept arguments. Now if you create another function here which kind of accepts 3, 4 or 5 arguments, you could still go ahead and make use of this decorator because this decorator can accept any number of arguments or no arguments at all. So this is how you could go ahead and decorate functions which accept certain number of arguments. So in the next lecture, let's go ahead and let's learn how to decorate functions that actually return a value. So let's learn about that in the next one. Let's take some practical example wherein a decorator kind of plays a little bit of role rather than just simply having some dummy examples. So let's say we want to create a function which kind of calculates the total price or the total cart amount, and then on top of it we want to add a decorator which kind of calculates the discount on that particular given price. So let's first go ahead and let's declare a regular function which is called as total. So I would say def total, and let's say this particular function is going to accept a price. So here I'll pass in price as the parameter. Now let's say the job of this function is to go ahead, perform some manipulations on this price and then return the price. So here I'll keep things simple and simply return the price. Now let's create a decorator. In this particular lecture, let's learn how we could decorate functions which return a value. So till this point we have created functions which accept an argument, but we have not created any kind of function which return a certain value. So let's take some practical example wherein a decorator kind of plays a little bit of role rather than just simply having some dummy examples. So let's say we want to create a function which kind of calculates the total price or the total cart amount, and then on top of it we want to add a decorator which kind of calculates the discount on that particular given price. So let's first go ahead and let's declare a regular function which is called as total. So I would say def total, and let's say this particular function is going to accept a price. So here I'll pass in price as the parameter. Now let's say the job of this function is to go ahead, perform some manipulations on this price and then return the price. So here I'll keep things simple and simply return the price. Now let's create a decorator which is going to calculate a discount on this particular price. So as we all know, we always have to create a decorator at the top, which is right before the function which we are decorating. So as this particular decorator function is going to kind of go ahead and calculate the discount on this price, I would go ahead and name this decorator as summer discounts decorator. So I would say def summer discount decorator. So now as this is a decorator, I have to pass in a function here. So let's pass in func. And then we need to have a wrapper inside. So def wrapper, and inside this wrapper we are going to call this function. So I will say func. And now as usual inside any kind of decorator, what we do is we return the wrapper, and that's it. So our regular decorator here is ready, but there are a few problems with this decorator. Now as I earlier mentioned, whenever you create a function and whenever that function accepts an argument, you have to pass in that argument to the wrapper. So instead of having keyword arguments, let's simply directly pass in price as the argument here, because this decorator is only limited to this function and this function only accepts price. Now here, once we have passed price to the wrapper, let's also pass it to the function as well. Now one thing which you need to learn here is that as this function now returns a certain value, unlike the previous case, in this case after calling this particular function we also have to go ahead and return that particular price as well. So let's say this summer discount decorator actually calculates a 50% discount on the price. So this time we'll make this thing return the function, then pass in price over here to this function, and as this is going to calculate a 50% discount on the price, I would say price divided by 2. So now what this does is that it takes the price, whatever price which we have, and it kind of discounts it by 50%, or it basically divides the price by 2. So now once we have this function, let's first call this function right away and let's see how it works without the decorator, and later let's actually call that function with decorator. So I would say print total, and then let's pass in 100 over here. So if I run this, it's simply going to return us back the value 100, because this is a simple function which accepts and returns the same value. However, now if I want to apply a summer discount on this total function, I simply have to make use of the decorator, which is summer discount decorator. And as soon as we do this, and if I run this, as you can see now it returns a price of 50. That is because we have actually made this wrapper a return function, and then we have passed in price divided by 2 here. That is, we have essentially manipulated the value of the price over here inside this wrapper. So this was just a simple example to manipulate whatever data which we have passed to the decorator, but you could also perform manipulations on your own as well. So this is how you could go ahead and decorate functions which return a value. So the only thing which you need to take care of is that whenever a function returns a value, you also have to return that particular value from inside the wrapper as well. So that's it for this lecture, and I'll see you guys in the next one. Thank you.
Alright. Coding challenge part 4. Create a BMI calculator, BMI, which stands for body mass calculated. Write Python code which can accept the weight and height of a person, calculate his BMI. Note, make sure to use a function which accepts the height and weight values and returns the BMI value. For the solution, refer to the next lecture. Alright. So the way I want to do this, I guess we could just make the whole thing a BMI calculator. I mean the whole thing a function. Oopsies. Hmm. So this is in kilograms and in meters. So I kind of have this weird, because I'm in America. I like to take these, um, let's do something like this, pounds, height, and inches, and then convert these, right, because I'm American, and we don't like the imperial system here in America. So I'm going to convert our weight in pounds and our height into kilograms and meters. And then I'm going to do the formula. So weight in pounds, and then, well, this is going to be weight in kilograms, weight and height in meters. That's good enough. Alright, let's do kilograms to pounds. I think it's 2.2. Technically, it's 1 kilograms equals 2.20405. So I'm going to do 2.205 in kilograms. We're going to do so we could do weight in kilograms equals weight in pounds divided by 2.205, because we're just rounding this number up. It's a little more. So let's do this. And then we'll do print weight in kilograms and pounds, and then weight kilograms. We'll just do that. My weight is 290. I'm a fatty. So 131. That's about right. So let's just do 131. Look at that. That's correct. But there's another way you can do it. I think you can also do this a little more simply. So I'm just gonna actually comment this all out, because I think I want to make it a more simple. And then what if we did this instead? So we do weight equals int input, please enter your weight, put the little comma or the note in pounds, So we're just going to do the weight for now. I wonder if this is a problem. And then we could do weight equals times equals 2.205 print weight. That is not correct because it's divided equals. That works. So that saves us from having to make a whole nother two separate variables. So we don't have to make weight in pounds and weight in kilograms. We could just make weight. We could even add a function. Well, we can add the option to make it kilograms or pounds, but we're not going to do that. We're just going to keep it simple. Yeah, we're going to do that. All right. I'm going to do the same thing to height. Everybody should know their height in inches if you're American. And then here we're going to I think it's the similar thing. Let's do height to inches to meters. This is 0.024. That's what we're going to put. I'm pretty sure it's still divided by. We're going to put that and then print height. Okay. So let's see what it says. Your weight 290, inches I'm 73. I'm definitely not 2,874 meters tall. Yeah, this is definitely multiplied. I suck at math. I actually want to get much better at math. That seems like about right because I'm about 183 centimeters. So from 73 inches to, oh, look at that, 1.8542. 1.8542. So then, now we can do the formula. So, I'm thinking make a variable called BMI and then do the whatever weight divided by height power 2 or and then return BMI or just return this. I'm just gonna do this because I think, I don't know, to me that seems cleaner, right? And that should work the same. And then instead of doing this, we could print. Oh, we can't. Can accept the weight and height of a person and calculate his BMI. And returns the BMI value. So, technically speaking, this function, okay, this is a function which accepts the height and weight. We have the height and weight, and then it returns the BMI value. So we're returning the BMI value here. So let's test it out here then, because that's technically what it's asking me to do. Then let's just go to BMI calc. Put mine in 290. Wait, enter your weight. Oh yeah, I could just copy my 519. Enter your 1.854. And then let's enter my years. I'm an old fart. Yes, thank you. Thank you for letting me know that I am OBCD. Super OCD. 382621. This is not correct. 38.2, not 38,221.2. Like for real though. Oh, because I put centimeters. Oh, that's funny. Okay, let's do that again. 131.519. And then centimeters, 185.5. 0.4. That's correct. Alright, let's see. 290 and 73. 38.254. So technically, I did what I needed to do while making myself a little more depressed. It's funny. For the record, I am hitting the gym, getting swole. I'm more focused on gaining muscle now than losing weight at the moment. Alright, I feel like that accomplished the mission. And technically speaking, I could have done it in this. But since I'm American, I don't know my own weight in pounds, and I don't know my own, or in kilograms, and I don't know my own height in meters or centimeters. So I did it like this. Because I gotta make it American, man. I'm in America. So what did he do? He made it a float and a float. But technically speaking, look, he said, oh, write Python code which can accept. Make sure to use a function. This is it. Make sure to use a function which accepts the height and weight values and returns the BMI. So technically, this can be put outside of the function right here, and then I could put this in there like this. New BMI, new weight. But why is it new weight? Calculate BMI, new weight, new height, new BMI equals new weight divided by pound new height, comma 2. I like my way better because this is a built-in function. That's the power of 2 right there. Wait, float, input. So that's the same thing, except I'm accepting an integer. Although, let's see, if I execute this and put 290.5, it's going to be mad at me. So it's probably better to put float in there, technically, because there's certain people that are crazy about their weight and care about a half a pound. So I guess that would be better. And same goes for height. Oh, my wife is calling. I'm going to mute you guys. Eventually I'll get a Stream Deck and whatnot, but I do like mine better in the sense that everything's in the function, but yeah, I succeeded in my mission. Just for shits and giggles, let's change this to float. Because even though, I mean, technically speaking, it should be a float because this automatically, when you divide it, this automatically turns it into a float number. And you're multiplying it by a float. So it's going to be a float. Which, if you don't know, a float is just a number with a decimal. And an integer is a whole number. No decibels. Alright, let's move on. Functions are used to reuse code. To create or define a function in Python, we use the keyword def. Okay, next. To execute code inside of a function, we must call the function. A function call is identified by parentheses. Given this func, display a comma b, print a, compare a and b in the above function are function arguments. Parameters. I suck at this. 10 and 20 up and above call are the arguments, yes. Given func definition, display a comma b equals 20. B is the default parameter. Yeah. These are parameters. Okay. Continue. Let's move on.
In this lecture, let's talk something about modules. So in the previous
Let me see, where am I at? This guy, if you guys want to learn how to program, this guy, I'm going to show you his thing because it's actually kind of incredible. So this guy last updated this program in October 2024. I purchased this course on January 10th, 2017. Yes, I know, I suck. I've been wanting to program for 8 years and I still haven't learned um, because I never took the time to do it. But now I'm doing it. But when I decided a couple months ago that I wanted to learn how to program, I just went through my Udemy because I remember back in 2017 I was pretty gung ho about it. But then I got into a new job and I just got totally sidetracked because my new job took up so much of my time and I kind of forgot about it. But I looked at Udemy because I was like, man, I wonder if any of my things are still viable. And I looked, and this dude, I don't even know when he put this program in, when he made this course, but he has been updating it since at the very least January 2017. We're moving on to 2015, 2025 here. This guy's been updating this dang thing for almost 8 years. Imagine that. And I've bought other courses. Like that's the guy, Ashtosh Pawar. And I've bought other courses that, you know, pretty much within a year after I bought them, they've been deprecated and no more updates. So this is pretty cool. I think I like this guy, and he breaks it down pretty simple. I mean, obviously, you know, if he doesn't do your style, you're not going to be able to learn from him. But he breaks things down pretty well, and he'll he'll give you he'll give you information that applies to future stuff, and you kind of learn a lot from him. Like he does go over a lot of stuff, and this is like legit too. Like some of the stuff, like I got as far as PostgreSQL and Tinker and we made a calculator app and he tells you how to make a user interface. He does use PyQt as well. um, I think this is pretty well rounded. I feel like this is once you get out of this you could probably escape that tutorial hell I hear so much about if if you just go through it and kind of do his recommendations, because he'll do stuff like this where, like for this for example, when I made this BMI calculator, he just told me to do it and let me loose. And then is this wrong? I guarantee you, if he'll say that this works, and that's his mission is to get you to make something on your own. I made this completely on my own, and I just made this adjustment right here when I looked at his code. You know, I even added the weight, um, the the to change it to kilos from pounds. I like this guy. I think he does a very good job in his course, and I highly recommend this thing. 'Cause you look at, he's got 80 hours of content, and I know that where is it? I don't even know where it is. Yeah, right there, 80 hours of content, and his content is just solid, man. Like he breaks down everything. Like he tells the introduction, installing. I mean, he shows you how to install Python and PyCharm, and he goes down in. Let's see, tells you about lambdas and file handling. You're gonna need to know that for like Postgres, SQL, and stuff like that. Um, and actually, you're gonna need to know that for when you write information to your program. Kinter, which is like your UI. This is as far as I was getting right here. This is where I stopped. And then I took a week off and a couple weeks off, and with the holidays and excuses, and I'm just going back to, if I wasn't 100% sure on what I was doing, I just went all the way back and did it. But he kind of runs you through it, man. And then look, let's see, like these are all the apps that he builds. Building a QR generator, credit card validation, automated CV generator, build apps with PyQt6. So he goes in and then tells you how to do everything. By the end of this thing, if you're consistent, right? I'm not consistent enough, so I kind of have to keep going back and forth. But if you're consistent with this, I think by the time you finish this, you should be able to make your own stuff, at least at the very basic level. I don't know. Moving on.
Meaning that if we have a large number of lines of code, what we could do is that we could actually split those particular code.
I'm wondering, why did I go? Because it went from sum of numbers, and went and turned. This is to return the duplicates, right? Now we went into here, and then why do we have
those particular code snippets into different. In this lecture, let's talk something about modules. So in the previous section, we have learned about functions, and functions are used to kind of group together a snippet of code and kind of assign a name to it. Now functions actually make our code modular, meaning that if we have a large number of lines of code, what we could do is that we could actually split those particular code snippets into different functions.
You know what I'm going to start doing? I'm actually going to go in, and then I'm going to exit this out, and I'm just going to make a big giant library of my code snippets. So refractor, rename, and I'm going to call this BMI underscore calc. And then I'm just going to keep adding, I think that's under here. Yeah, let's do this. And then we'll just name it demo.py. And I'm pretty much going to just save whatever oh, that's weird. Let's just make this up here. Why not? I don't know why it made an external library as well.
And use those functions as and when required. However, when you write large applications, even those functions are not able to contain all the code which we have. And therefore, we need something bigger which actually contains the code. And that is what is called as a module. So you can say that a module is larger than a function, and a module could contain multiple functions comprised together. So for example, let's say if you're writing a large application, that large application is going to have functions, maybe hundreds or even thousands of functions. So managing all of those functions inside a single file is going to be quite difficult. Henceforth, what we do is that we actually go ahead and split those particular function across different files, and each file is actually called as a module, which might contain a collection of hundreds or even thousands of functions. Now in Python, there are two types of modules. One is the built-in modules, which are provided by Python, and we could use them. That means there are some modules which come built in along with Python, which we could import and use in our current code. And also there are other modules which are created by other programmers like us. And the second type of modules are what we are interested in right now. That is the module which we could define on our own, and we could have our very own set of code in there. So in the next lecture, let's go ahead and let's define our very own module, and let's add some kind of code into it, and then let's learn how we could utilize that particular module inside our main file, which is this demo.py file right here. So in the next lecture, let's go ahead and in this lecture, let's learn how we could create a module. So in order to create a module in Python, you simply have to first go ahead and create a new file. So let's assume that this demo.py file, which we have up over here, is our main file from where the main execution of the program starts. So we want to create a module which is kind of external to this, and that module needs to have some code, and we will learn how to use that particular module's code inside our main demo.py file. So in order to create a new file, click on the projects tab, and here I have actually created a file which is pro.py. You could ignore that. We are going to be creating a new file here by clicking on this project, go to new, and create a new Python file. So whenever you have to create a module, you can simply create a module by creating a new .py file. So let's go ahead and let's name this particular module as greet.py. So let's say the greet.py module is used for welcoming users of our application. So let's name this module as greet.py. Okay, so as you can see, there's nothing fancy in here. This is simply a file similar to the demo.py file which we have up over here. Now, as I earlier mentioned, a module is one level above a function. That means a module is going to be a collection of functions which we could use. So in here, for learning purposes, let's create a plain and simple function which simply says welcome to the club. And let's name that function as hello. So I would say def hello. You could name it anything, but I'll name it hello. And then here, I'll make this particular function print a simple string like welcome to the club. Okay. So now once we have this function, you could run this file itself and you are going to get the result. However, as we are learning about modules, we will now learn how to use this greet.py module inside the demo.py file which we have here. So if you take a look, the demo.py file and the greet.py file are actually present in the same directory. But to use the function hello from greet.py to demo.py here, first of all, you have to import the greet module here. So in order to import the greet module here, I simply use a keyword in Python which is called as import. So I would say import, and then I simply have to name the module which I want to import. Now this module which we have here is named as greet, so I will say import greet. Now what this import greet statement allows us to do is that it allows us to use any function which is defined here to be used inside this demo.py file. So now the question is, how exactly could I go ahead and access this hello function which I have? So in order to access that hello function, as that function belongs to the greet module, I would say greet, then use dot, and then say hello. Save this, and now what we have essentially done here is that we are making a call to the hello function. However, as this hello function belongs to the greet module, I need to say greet.hello. Now if I save this, if I run this, now as you can see, we have executed the demo.py file, but the code inside the greet.py module was called and the function hello was executed, which gave us this output, which is welcome to the club. Now this module which we have up over here, it could contain multiple functions as well. So for example, I want to create another function like buy. I would say def buy, and let's say this function displays some other message like, let's say goodbye, thanks for the visit. Now once we have this function defined, in order to use that over here, we simply have to say greet.buy because the greet module is already imported. So I could say greet.buy, and now a def buy, and let's say this function displays some other message like, let's say goodbye, thanks for the visit. Now once we have this function defined, in order to use that over here, we simply have to say greet.buy because the greet module is already imported. So I could say greet.buy, and now the buy code will be executed. So as you can see, first it executed the hello message, then it executed the function which displays the goodbye message. So a module could contain as many number of functions as we want. Now there's one more way of calling functions from a module. So here as you can see,
I'm just messing around with this. Alright, let's go import greet.
we have imported the entire module which is the greet module. And as we have imported the greet module, we had to say greet.hello and greet.buy. These function calls which we have over here, they kind of look a little bit different because usually the way in which we call the functions is that we simply say hello and we simply say bye, which actually look like a function call. So in order to solve this problem, what we do is we want to tell Python that, okay, from the greet module, I want to import a particular function. So here, instead of saying import greet, I would say I want to import hello and bye from the greet module. So in Pythonic terms, we have to say from greet, that means from this module, I want to import, and then I could name the functions which I want to import. So let's say I only want to import hello, so I could type in hello here. And this time if I have to call hello, I simply could say hello, save this, and if I run this,
I think I just figured something out with this. I'm gonna do oh, nice. So I can hit F12 and that's gonna take me down. What if I, well, I can't go back. How do I go back? Oops. Oh, I done messed up, Aaron. Well, at least that's one nice thing. Hmm. Whatever.
As you can see, now it executed the hello function out of the greet module, and we don't even have to write greet here. That's because we have imported the hello function itself from the greet module, whereas in the previous case we were importing the entire greet module. However, now if I say bye, this will give us an error because we have not imported bye here. So if you want to import multiple functions from a specific module, you just have to give a comma and import that function over here as well. And as soon as you do that, as you can see, now the error from here is gone. So if I run this,
This kind of seems to be like an ongoing thing, right? Because if we made 0 and b equals 1, whatever, we could say print a and print b, and that's going to print it. We got 0 and 1, and then we can print a comma b, and that's going to make it just print next to each other. But it's possible, and you also do the same thing in functions. So anyways,
you can see, now both the functions work without any issues. So this is how modules work in Python. And most of the times during the duration of this course, we won't be creating our very own modules. However, we will be using a lot of third-party modules which are created by other developers because we actually need them to build our web applications. And you need to know how exactly a particular module is imported and how exactly the different functions inside those particular modules are imported as well. So that's it for this lecture, and in the next lecture let's learn some of the built-in modules which are present in Python, and let's also learn how to use them. So thank you very much for watching. In this lecture let's learn how we could use the built-in modules in Python. So as discussed previously, most of the times in our code we will be making use of the modules which are built in, or we will be using some third-party packages and modules. So we need to learn how we could use those particular modules. So for this lecture let's use a built-in module which comes built in with Python called as the random module. So in random module, there are multiple functions which could be used for multiple purposes, like generating a random set of numbers or integers whenever our program needs to. So let's go ahead and let's learn how to use that. So first of all, let's read the code from the previous lecture, and let me also close this as well. So now you need to understand that in the previous example, we were actually making use of a module which we had created. But right now we will be making use of a module which is already installed. So you won't be able to see that over here, but it actually is kind of set up on our machine whenever we have installed Python. So here I would import the module. So in order to import the module, I would say import and I would say random. So as you can see, the auto suggest over here is automatically suggesting the random module for us. Now this particular random module has a multiple set of functions which we could use. So now let's say we want to generate a random number by making use of this particular random module. So this random module actually has a function called as a randint, which generates a random integer for us within a specified range. So in order to use that particular function from the module, first of all I have to say random in order to be able to access the functions from that, and then say dot randint. And then over here, this random integer actually accepts two parameters, that is the range in which we have to select a random integers. So let's say we want to have random
That's
integer.
cool, because I put those two, and it's just constantly going different numbers. That's pretty cool.
Selected from the range 1 to 10, I could specify that range over here. And this particular randint function is now going to give us back a result. So let's save that result in a result variable. So this result is going to be some random integer, which is randomly going to be generated by this function. And then let's print this, so print result. And now let's try running this code and see how it works. So if I run this, as you can see, out of numbers from 1 to 10, randomly this particular function has selected a number 2. Let's run it again and let's see if we are able to go ahead and print and get a random number. So I could run this, and now this time it gave us 10. So every time we execute this particular code, it kind of gives us a random number within that range. So using this, you could actually also simulate the rolling of a dice as well. So on a dice, they are typically numbers from 1 to 6. So instead of 1 to 10, I could say I want numbers from 1 to 6. And now as you can see, we have a virtual dice here, which randomly gives us numbers from the range 1 to 6. So as you can see, every time we run this, we are getting a random set of number. Now, as earlier mentioned, if you only want to go ahead and call the function without actually naming a module here, what you could do is you could import only this function from that module. So instead of saying import random, I could say from random import the randint function. And now I could get rid of this line from here. And instead of saying random.randint, now I could directly call that function itself. And even this is going to work absolutely fine without any issues. So if I run this, as you can see,
So there's randint. So you gotta learn how to like understand this, because I'm not really entirely sure what this means, right? Sample x comma k equals len x. Instead, to shuffle an immutable sequence and return a new shuffled list, use sample instead. Note that even for small len x, the total number of permutations of x can quickly grow larger than the period of most random number generators. Yeah, I don't really understand that, to be honest. Yeah, I imagine it'd be pretty good to have a good grasp of this. But
still the random set of integers are being generated. Now, similar to the random module, we also have some other modules as well, which we could use whenever we need them. So in the next lecture, let's go ahead and let's learn about the datetime module in Python, which allows us to go ahead and get current date. So let's learn about the datetime module in the next lecture. In this lecture, let's go ahead and let's learn about using another module called as a datetime module in Python, which is an inbuilt module which provides us with functions which actually allow us to go ahead and perform multiple operations with respect to date and time. So let's say in a Python program, if you want to get the current date and the current time of your system, in that particular case, you could use the datetime module. So let's go ahead and let's use that. So in the random module, we used to have a module, and then inside that module, we used to have functions. However, in a datetime module, the code which we will be using or importing is actually present in a class format. So classes in Python are similar to that of functions, but they are a little bit different, and they are kind of used in the object-oriented programming paradigm. And we have not yet learned about classes as of now, but we are going to learn them in the later part of the course. But for now, let's understand that classes are nothing but they are something which contain methods, and these methods are similar to functions. So let's go ahead and let's get started using the datetime module. So obviously, whenever you have to import some module, you say import and the name of the module, which is in this case datetime. Now once this module is imported, now we could actually go ahead and make use of it. So let's say if you want to go ahead and get today's date using the datetime module. So in order to get today's date, I would say datetime, which is the module name, and instead of directly going ahead and accessing the function inside the datetime module, as the datetime module contains classes, from the datetime module we have to use a date class. So therefore I would say datetime.date, and you'll be able to see that this date over here has a notation which is C. That means this is actually a class. So I would say datetime.date, and in a class you could have multiple methods or functions. So instead of directly having a function in there, we instead have those functions, and the functions which are actually present inside a class are usually referred to as methods. So here I would use the method which is nothing but today. So as you can see, I could say today, and you'll be able to see that this has a notation M, which means that this is actually a method. So here I would say today, and we call a method just as we would call a function by adding a set of parentheses over here. Now this particular thing returns us today's date. So let's save today's date into something. So I would save it into a variable called as today underscore date equals datetime.date.today. So datetime here is actually the name of the module. Date is a class inside the datetime module which contains multiple methods like today, and today is the method which actually gives you access to today's date. So once we save this, we could now print the today's date as well. So I would say print and print the today date, and let's see the kind of result we would get. So if I run this, as you can see, I will get today's date here, which is 8th March 2023, which is actually correct. Now let's try to go ahead and let's try using another method from the datetime module. So let's say, for example, just as we have gotten today's date, let's say we want to get the current time as well. So in order to get the current time, first of all, I'll create a variable called as current time. So current underscore time. And here I would again make use of the datetime module. However, this time, in order to access the current time, the class which I need to access is the datetime class, which is already present in the datetime module itself. So I would say datetime.datetime, and as you can see, the datetime here is actually name of a class, and it's not a module here. So inside the datetime module, we again have a datetime class as well. So I would say datetime.datetime, and then in order to access the current time, I have to say dot now. So now is actually a method which is used to access the current time. So here if I save this, now this actually returns the current time. So here right after the date, I would print the current time as well. So if I save this and let's run this, and as you can see over here, this today date actually returns the current date, and this current time actually returns date along with the time. So if you want to purely get the time from this, here from the current time, you could even say dot time. And here as you can see, if I say current time dot time, it will only return the time section for me. So as you can see here, we have access to the current time. And if you want to get access to the current time as well as date, in that case you could simply say datetime.datetime.now, and that will give you access to the entire date as well as the current time as well. Now another way to write this in sort of a much better way is to go ahead and import the classes here and then invoke the methods on those classes. So here instead of saying import datetime, I would say from datetime I want to import the date class. Along with this, I also want to import datetime as well. So here I would say datetime. Okay, so now as we have imported classes here, now I don't have to say datetime.date and datetime.datetime. As I have already imported those classes, I could simply go ahead and get rid of the module name here and instead directly make use of the class name. And then to use the method inside the class name, I would say dot the method name. So the same could be done over here as well. So if I save this and if we run this, as you can see, this is still going to work in an exactly same manner. But this code looks more appropriate and precise, and you could get rid of the import at the top. So that's it for this lecture, and this is how you could go ahead and make use of the built-in modules which are provided by Python. Now, when we design some complex applications in Python in this particular course, we will be using a couple of third-party modules as well. So we will be using a tool called as pip to install certain third-party modules. And when we install those modules, you could then use those particular modules in your Python code just like that by importing certain methods or certain classes from those particular modules, and then making use of those classes, functions, and methods inside your code. So that's it for this lecture, and I'll see you guys in the next one. Thank you. Hello and welcome to this plan.
Okay, I'm done with this. Now we're going to place some oxygen not included. Yeah, stand by. I'm actually going to see if I can change the stream. Hey, look at that, it changed it. That's pretty nice. I wonder if it's gonna... Oh, so it started a second stream?